Homework sheet U11d question 5. Part A, we've got a table to complete by just substituting in x equals 1.5 and x equals 2.5 into the given equation. If we plug in 1.5, we get half log 3 over 2. And if we plug in 2.5, we get 3 over 2 log 5 over 2. In part B, we're asked to use the trapezium rule. In part 1 of this, we have two trapeziums because we're just using y values at 1, 2 and 3. This gives us a h value of 1, difference between 1 and 2 and 2 and 3. Our integral then is h over 2, so 1 over 2, lots of first term, 0, plus last term, 2 log 3, plus 2 times all the terms in between them. There's only one this time, log 2. And if we put that into a calculator, we get 1.792 to 4 significant figures. In part 2, we're using all our points to use 4 trapeziums. This gives us a h value of 0.5. So 0.5 divided by 2 is a quarter. Our first term and our last term are still the same, but this time we've got more terms in the middle. Half log 3 over 2 plus log 2 plus 3 over 2 log 5 over 2. And if I put that into a calculator, I get 1.684. 4 significant figures. Part C asks us to explain, with a reference to the diagram, why an increase in the number of values improves the accuracy of the approximation. The reason is that the accuracy is improved as the error is reduced, as each line segment at the top of the trapeziums is now closer to the actual curve. I don't think that's the best explanation that I could do, so I've given a diagram to improve my answer here. It's following the rough shape of the curve between 0 and 1. If I've just got a single trapezium there, there's a rather big error there. If I split it up into 2 trapeziums, I've still got a bit of an error there, but the one here is almost gone entirely. And the diagram just improves my answer and makes it clear that I do know what I'm talking about. In part D, I need to actually do the integration rather than just the approximation that I've done earlier. This is integration by parts. Normally you set u to the polynomial part and dv dx to the non-polynomial part, like an exponential or a trigonometric function. The natural log is the exception, and I'm going to set u equal to log x and dv dx equal to x minus 1. If I differentiate log x, I get 1 over x. If I integrate dv dx, I get x squared over 2 minus x. In my integration by parts formula, I get uv, which is x squared over 2 minus x lots of log x, and that needs to be between the limits of 3 and 1, minus the integral of v du dx. So I can divide each of my terms in v by x to get x over 2 minus 1 with respect to x. And this is something that I'm able to integrate without any problem. So my final answer, before I do my substitutions, is x squared over 2 minus x lots of log x minus x squared over 4 plus x, because the minus and the minus. If I make my substitution for 3, I get 9 over 2 minus 3 lots of log 3 minus 9 over 4 plus 3 minus a half log 1 plus a quarter minus 1. Log 1 is just 0. So if I simplify these, 9 over 2 take away 3 is 3 over 2 log 3. And that's all that I need, so I've got to just check that all the other numbers do add up to get 0. So if I combine that together, I get minus 9 over 4 minus a quarter plus 1 minus 3. 9 quarters, take away 1 quarter is 8 quarters, which is 2, plus 1 is 3, take away 3 is 0, which is just equal to 3 over 2 log 3 as required.